Hey everybody, it's Mrs. C, and oh my gosh, what is this on my screen? This doesn't look like my usual math because it's not really my usual math. This is a blending, everybody, of a little bit of science and a little bit of math. So I know that in classes you've been working on density, volume, and mass. So you've been converting either from to given density or given mass or given volume, and finding the missing value. And though this is just a scunch bit outside of my usual presentation, I want to go over this because this is based completely on the algebraic process we've been working on, and I felt that I would be remiss if I did not go over this with you guys and just give you my spin on it. So here we are being asked to find the unknown quantity. We're given in A, we're given the density, we're given the volume, and we're missing the mass. Even if I didn't know what this was about, I could still solve for mass as long as I know my density formula. So I happen to know my density formula. Do you? What is it? Excellent. Density is equal to mass over volume, or mass divided by volume. So as long as you know that density is equal to mass over volume, you can easily find these answers. Now, for now, I'm not even going to look. I know your science teacher, and I won't name any names, is going to be furious that I'm saying ignore the labels for now. I think it's important, so just ignore the labels. Let's go with the math. Now, you know when I do an evaluation, and that's all this is evaluating, I usually use a different color to swap in the values. So let's see. We have D equal to 3. So I'm going to throw the 3 there. And then what's another value that we have? We have, let's see, we have volume equal to 100. So that's 100. We're looking for the mass. So if I was to rewrite that, and I'm just going to go back to one single color now. Oops, sorry, my screen is falling off my pillow. I have a 3 equal to mass divided by 100. Now I want to point out, everybody that's been working so diligently on proportions, this is just a proportion. Imaginary line there. It's really a 3 over 1 equal to an m over 100, and you can just use cross products to solve that. However, maybe not the way you're seeing it in science class. So I'm just going to show you a typical algebraic process for solving this would just be to get m by itself, right? So if this was the line drawn, we would multiply both sides by the denominator, which is 100. They would cancel out, and we'd be left with mass equal to 3 times 100, which is 300, and that would be my answer. Now, mass then would be equal to 300, and I'm not specifically, I know I shouldn't do this, but I'm not going to go over those labels yet. Number one, it's too early, and I'm not sure what the label is. And number two, I want to get to finish the rest of the problems and show you why I'm skipping the label. All right, now you can see I have a little problem. I just did a little peekaboo there. Oops, another peekaboo. I'm hiding the rest, not because it's a secret, but because it's kind of in the way. So there's a little bit more to this page that I'm avoiding right now. All right, so let's go with density equals mass over volume. It's the only formula you need. And this time, let's just swap in our values without the color coding. Do I know the density? I'm on letter B. No, I don't know the density, so you'll be a D. Do I know the volume? Yes. Pretend I don't know or care about labels. Volume is 950. Volume is in the denominator, so 950. And the mass is, don't look at the label, 95. That would go up here. Okay, so the first thing that I would want to do is to what? Yes, I would agree. Let us multiply both sides by 900. Now, why would I want to do that? Usually, you would multiply both sides by the denominator to get the letter by itself, the letter that you're solving. But what? the letter that I'm solving is by itself. So yeah, I could multiply both sides by 950, but then that would bring that little 950, woo, over here, and then I'd have to undo that and be, woo, right back here. So no, I'm not going to multiply both sides by 950. I'm going to get my answer, which is, woo, here already. I know I confused you with all the arrows. The answer is 95 over 950. Now, 95 over 950 is most definitely not the answer you would write in science class. It's the answer you would write in algebra class, and let's try to understand why. In algebra, we want to work with true answers, the truest form of an answer. An answer is in its truest form when it's in its fractional form, because ordinarily, when you work with fractions and you convert them into decimals, you have to round. Rounding loses value. Whenever you round, you lose value. So whatever the value of 95 over 950 is in decimal form, I'm going to lose value if I round it. Now, I could also go to my calculator and see that this comes out in a nice simple decimal, like 1.2. I know this is not 1.2, first of all, because the numerator happens to be smaller, so it can't be a 1 point anything, but it could be like a 0.23. And if it was, I would say, oh, I like that decimal because I didn't have to round it. I don't know what this decimal is going to be, nor do I care right now. I'm going to leave it just like it is, 95 over 950. Now, we have to agree that I am breaking all kinds of science rules. I'm leaving my answers in fractional form, which just looks strange in the science world. And the other thing is I've dropped all my labels, and that's a big no-no in science and in math word problems. So I'll be back. Relax. I'm just enjoying the math right now, aren't you? All right, letter C. Don't answer that. Letter C. I've still got my density formula here, so I'm going to leave it there, and I'm going to input my values. So I know that my density is a 0.5, and density, you're right there, so 0.5. Yes, here goes another one. I don't put zeros in front of my decimals. I don't like decimals to begin with. I don't want more numbers. I want the least amount of numbers I have to deal with because I don't like decimals. I like fractions. I'd much prefer to be using a number 1/2 right now. Oh, well, I'll deal with it. So 0.5 is equal to volume. Don't know it, so I'll put a V. And mass is 20. That goes up here. Now remember, we're trying to get the letter by itself, the one that I'm trying to solve for, which in this case is V. Now sometimes it takes a couple moves to do that. The first thing you want to do here, guys, is get the V by itself. But the problem is it's in the denominator, so it's not as easy as it was in the first problem that we did, where we just multiplied by the denominator and boom-a-zoom, we were done. This time we're going to multiply by the denominator, absolutely, but it's going to take a double move. Watch. When I multiply by V, the V cancels on this side, 20. Sorry, forgot about that. And then what's V times 0.5? It's 0.5 V. Now my V is on the left side, but the good news is it's not in the denominator, so it's going to be pretty easy to get it by itself. Now I'm going to divide by the number that's touching it, so dividing by 0.5. And you're done there. V is equal to 20 over I'm going to put an arrow because I'm out of space. 20 divided by 0.5, or 20 over 0.5. Now, talk about your tacky numbers. You just don't leave decimals in denominators. That's like a double division problem. That's 20 divided by 1/2, which I actually know that 20 divided by 1/2 is 40, but I'm going to pretend I don't, and I'm going to put 20 divided by 0.5 right there, and I'll come back to how I knew it was equal to what it was equal to. Now, let me erase my screen here. Let's see if I can make my eraser a little bigger. You're going to see the problems kind of that I'm hiding from you. I'm not trying to be sneaky. I was just trying to keep the screen clean. In my attempts to keep the screen clean, It looks like I'm hiding something. I'm not. I just wasn't planning on doing those problems on this video, so let me get them back out of the way again. It's a little annoying, but then I get this opportunity to kind of chit-chat with you. Okay, now I'm feeling like I'm going to just want to grab my calculator because it is early and I don't want to make any calculation mistakes, and then I got to do my labels. So I'm excited about this. I'm going to erase. Oops, that's not erasing, is it? No. I'm going to erase all of my canceling and hiding all these labels. I'm going to go there. I'm going to pause real quick. I'll be right back, but I'll be back with my calculator. Okay, everybody, I'm back, and I'm making sure I'm recording, because last time I did this, I thought I hit the button, and I didn't, and I was talking for like an hour, and nobody was listening. So here's my numbers. I did my calculations real quick. So 300 was easy. 300 is 300. 95 over 950 is a simple 0.1. I don't hate that decimal. I still prefer 1 over 10, but 1/10 is not that big of a deal, so I'll accept you 0.1. And then 20 over 0.5 is the same, like I said before, as 20 divided by a half, which I knew is the same as dividing by a fraction is the same as multiplying by its reciprocal. You might remember that, or you might not. Either way, 20 divided by 0.5 is equal to 40. So the only thing I have to do here, guys, is get my labels, and I'm going to give you the biggest cheat ever, so I hope you're listening. Let me bring the screen closer to me so that nobody else hears me tell you this. I always get confused when I'm doing my labels. It's why I left it to the very end. And when you're taking any kind of an assessment on conversions, don't tell anybody I told you this. All you need to do is look at the way they set up the labels in the problem and compare it to the way they set up all the other labels in all of the other problems. Let me explain what I mean. You can use the test or the quiz itself to help you figure out the proper label. Let's try letter A. So you see letter A, I have the number 300, but for mass I have to actually label it with its measure, whether it's grams, meters, liters, kilometers, whatever, millimeters, whatever you're doing, you have to put the label. So just look at the other problem. It was identical. It was, the volume was in milliliters, the mass was in grams, and so it's pretty easy for me to label my answer 300 because it's a mass. How did they label the other one? The other one was labeled G for grams. So guess what? It's going to be 300 G or 300 grams. That would be the number, the letter you see here. So if you notice, it's mass over volume, right? Density is equal to mass over volume. So if the mass is what I'm missing, I just have to look to see what was the density. The density was in grams. What was the volume? The volume was in milliliters. And so all you need to do is notice that the one that I would be missing would be, now what did I put that? Oh, shoot. Forget I said that. I was trying to say that density is equal to, oh my gosh, push through, stay calm, I'm good, rewind, stop, don't listen to anything I just said. In fact, okay, rewinding me, don't rewind me, I'm going to rewind me, and I'm going to play back. If you got confused, stay calm, just breathe. Let's pretend I never said anything, and we're going to go, because I've already been recording for 14 minutes. I'm not starting over again. So, density is equal to mass over volume. We all agree. So if it says right here that the density is equal to grams over milliliters, then my volume must have been milliliters. See, it's in the volume position. And my mass must have been in the grams. See, it's not as hard as any of us make it out. It's actually quite simple if you don't overcomplicate it. Let's try the next one. Oh my goodness. Alrighty. Now, I'm going to erase this because I want to clear our minds. I'm going to think about what I say before I say it. Density, mass, and volume. So density, I'm looking at letter B. Density is equal to mass over volume. So in this case, they told me the volume was milliliters. That's ml. And they told me the mass was G. So if density is equal to mass over volume, that is, density is equal to this. Now in science, we don't write it top to bottom, we write it sideways. So we would say density is equal to grams divided by milliliters, or grams over milliliters. And if you notice, that is how the density was shown in the prior problem. See it right here? G over ml. That means this one should be G over ml as long as you're working with the same units. And we are. They're both G over ml. So that would be grams over milliliters. That would be the label for our 0.1. It would be 0.1 grams to milliliters, grams over milliliters. All right. I did that one much better, don't you think? I think so. I am not as nearly as confused as I was before. Now, let's try the last one. Oh my goodness. This one's different. This is grams to centimeters cubed. Fear not, young ones. It's as easy as knowing what you're talking about, which isn't so easy. Density is equal to mass over volume. So just put in the labels that you already know. We know that the mass is going to be grams, right? So we know that our mass is in grams. Now, what were we trying to solve for? We were trying to solve for volume. Now, I can see that the volume is the unit that's missing, right? I already have, let me color code here a little bit. I already have the G, here's green, right? I've already got the green component. So what am I missing? I'm missing the other component, the centimeters cubed, which is the volume. So if you don't overcomplicate things, you can see very easily that the label that's missing is going to be the centimeters cubed, which is how you label volume in cubic centimeters. So then the answer for 40 would have to be in cubic centimeters. Oh my gosh. I am just, really? I don't know if you just saw what I did to the screen. Maybe you didn't. I hope not. So that the volume would be in cubic centimeters or centimeters cubed, because it's the only label in the density that isn't there. And if you notice, whenever you do this top one, the first, or the numerator, is going to be your mass, because it's mass over volume, and the denominator is going to be your volume. So whatever you had in that position would then go into the volume position. So it's really like filling in the blanks. It's not crazy complicated. I make it way more complicated than it is. All right, now down here, I think it's actually worth, let's see if we can clear the screen quickly. Erase all strokes. Oh no, if you erase all strokes are erased. So let me just bring that back to you. In the sheet that I had originally erased, and it's back up, here we go. This is it. This was what the bottom looked like. So we had just done that, and hey, now it's nice and clear. Why don't you take a moment to go back and do this by yourself without me confusing the issue, and see if you can actually pull that off. Now, I liked this, and I'm going to show this to your science teacher because I think that it's pretty cool, and I think it's worth doing. There is a little extra step to convert first to grams or milliliters, and what that means is you're going to see that they give you something in liters. They're asking you to convert it to milliliters. Why? Do you see why? Because that's what you're going to be working with. The density is given to you in milliliters, so it's grams to milliliters. So if they give you it in liters, you have to do your metric conversion 2 milliliters before you can even do the problem. That's a saucy one, isn't it? Oh, I like it. It's an extra little saucy step. Now, do you remember how to convert your metrics? Well, it's as simple as remembering King Henry died unexpectedly drinking chocolate milk. That's how I like to remember it. It's kilo, hecto, deca. Right there is your units position, which are your liters, your meters, and your grams. Liters, meters, and grams. So we have kilo, hecto, deca, liters, meters, grams. That's the unexpectedly standing for the units, right? Those are the units. Don't usually put that. So King Henry died unexpectedly drinking chocolate milk. These guys are the little lowercase ones because they're less than a whole. So you have your deci, centi, and milli. So kilo, hecto, deca, liters, meters, grams, deci, centi, milli. And it's as easy as moving across this little chart. You've done it before. You'll do it again. I'll do a video on metric conversions for you just to help you out. But just to do this one real quick, if we're going to convert 1.2 liters into milliliters, I start in the liter position, which is on my units. That's here. And I have to move to the milliliters. So I have to go from the center, 1, 2, 3 to my milli. How many moves was that? That was 3 moves. And who moves? The decimal. 1, 2, 3. So it would be 1,200 milliliters. So then what I would do is I would convert that without all of these arrows, and I would rewrite that to 1,200 milliliters. Makes sense because a milliliter is much smaller than a liter, so it would take a whole bunch of them milliliters to fill 1.2 liters. So you're moving to the right because if you look back up here, I'm back up here now, we moved to the right. When we went from liters to milli, we made 3 moves to the right. And so to move from 1.2 liters to milliliters, you'd move the decimal 3 places to the right. Really simple if you don't overthink it. I actually enjoy these a lot more than I enjoy labeling. So here's some problems for you to try it. I'm not going to do it. I don't know the answers. I'd show you the screenshot if I did, but this worksheet didn't provide me with an answer. So I say we throw this over to your science teacher and let her work a little bit, huh? Worky, worky in the science room. And until then, guys, I'll see you on the flip side.